Okay, 7th grade, our objective, finally, I know you've been waiting for this, is to simplify radical expressions with imaginary numbers. So you finally get to see, where's your calculator, Zach? Borrow either a little one or go get yours from your locker. So we're finally going to see what imaginary numbers are, how to simplify them, what they're actually used for. So what I'm going to do is introduce that, and then I'm going to start you off with the quadratic formula, because if we start off with it today, it'll be easier to learn the song tomorrow and for you to memorize it. Yes. Yes. It was good. Thank you. At the end of class, I'll tell you guys about that. Thank you, Gigi. Kevin.
Will you ever use it?
Yes, you will. Okay, imaginary unit I. So I want you to write down. I is equal to the square root of -1. You probably remember me saying, and Ms. Wingrove saying throughout this year, that you cannot take the square root of a negative number. You are not allowed to have a negative inside the square root symbol. Does anyone remember why? Do you remember back at the beginning of the year? Gigi, do you remember why? Okay. Anyone remember back in September? Kevin, shh. There was, in chapter 9 in particular, Eric? Well, correct, but in chapter 9, Jared? Yeah, but in chapter 9, whenever we were factoring and graphing parabolas, remember when I told you if there was an imaginary number, what would the parabola look like? Luke B? No, it would. Okay, so here's what it would look like. It would not cross the x-axis because if you have a negative inside, there's not an x-intercept. You cannot have an imaginary number for an x-intercept. So in other words, the application to this is when you're graphing parabolas and when you're factoring, if your x-intercept is imaginary, you can still graph it, and I will show you that at some point, but it's going to be up in the air. Okay? So, an example, I want you to write down square root of -25. Square root of -25. So what we would do is we would break that down like we did when you guys watched the gold packet videos into square root of -1, square root of 25. The square root of -1 is I. So you represent that as I. The square root of 25 is 5. So the answer is 5i. All you do is change it to be square root of -1, square root of 25, or whatever the number might be. The square root of -1 is always equal to I, which tells you there was a negative inside the square root. It's an imaginary number. What I need you to do underneath or next to that is we are going to make a list because there's a pattern here. So let's make this list. I want you to start with I to the 0. Okay, I to the 0 is what? Anything to the 0 power, Eric? Anything to the 0 power is 1. So I to the 0 is 1. Shh, Kevin. I to the first power is just I. Okay, so here's something you need to think about. What do you think I squared is? What do you think I squared is, Nathan? Nope. I squared. Luke B? Nope. Eric? Nope. Look, if we square this and we square this side, what's I squared? Gigi? Yes. Good. Listen to that. I squared is -1 because when you square both sides, the square root's going to cancel. So they're both gone. If you square a square root, it's gone. So I squared is -1. Okay, what do you think I to the 3rd is? What do you think I to the 3rd is, Nathan? Nope. I to the 3rd, Luke B? Nope. Gigi? Nope. Luke C? Why? How'd you get that? What's the pattern? Well, look at what we look at. Good job. I to the 1st is I. I squared is -1, so I times -1 is -I. Okay, so we're going to go back to that. I to the 4th to make a second column. Yes, I to the fourth is 1, because you could go back and say negative 1 times negative 1 is 1. I to the fifth is I to the sixth is negative 1. I to the seventh is negative I. This keeps going. So I'm just going to write those 8. This pattern keeps repeating, and as Gigi was saying, you can use what we already know and keep multiplying to find what the next I to the whatever might be. This is not something you need to memorize, but we may do a little bit of complex numbers tomorrow, so you can actually see, well, how would we graph these? What would these actually look like? But for now, I just need you to know the square root of negative 1 is represented as I. Gigi? Yep, we're going to do that right now. Okay, so let's do some examples. Number 1, square root of negative 49. First thing I always want you to do is separate them. Square root of negative 1, square root of 49. Luke B. Okay, go ahead. Good job. Square root of negative 1 is always I. Square root of 49 is a perfect square. So we're going to leave the answer as 7I. Pretty easy, right? It's imaginary. When you go to graph it, it will not cross the x-axis. It'll be up really high or down really low. Number 2, first thing you want to do is separate them to be square root of negative 1, square root of 33. Can you take the square root of 33 and get a nice answer? No. Is there a perfect square that goes into 33? Nope. So your answer here is I square root of 33. I square root of 33. It's because you can't do anything else. Okay, square root of negative 27. We need to break that down into 3 things. Gigi, what can we break it down into? Good job. So square root of negative 1, and then you know 27 can be broken down into 9 times 3. So what would our answer be? Nathan?
3I times the square root of 3.
Good job. 3I times the square root of 3. Okay, number 4. We can break that down to 3 things. What can we break that down into? Kevin, what's a perfect square that goes into 54? You're not paying attention. So what's a perfect square that goes into 54? Whoever just said that, Luke C. Kevin, you know your multiplication tables. What's a perfect square that goes into 54? Good. What times what is 54? Try 6. And what else? Okay. What else, Kevin? Okay, pay attention, please. Okay, Anna, what would the answer be? Good. 3I times square root of 6. All right, easy, right? Okay, I figured that. I want you guys to try 5 and 6. Try 5 and 6. Split it up, break them down. So just try 5 and 6, and then put your pencil down when you're done. Remember, square root of negative 1 is I. Okay, Eric, what can we change 80 to? Square root of negative 80x cubed, I should say. Okay. Okay, what else? Good job. Who can remind us of the rule? If you have a variable squared, or a variable to the something power. What's the rule there when you're taking square roots, Gigi? Good job. If it's an even number, someone besides Gigi tell us, and you take the square root of it, what do you do? Luke B. Good, divide it by 2. So this is something we haven't done in a while, but you should remember. Thanks, Zach. So what should the answer, Andy, be for number 5? Awesome. Number 6, Anna, what did you get? Oh, I'm sorry. I'm going to give you guys another minute. Yeah. No. It could be in the middle, yeah. The I does not have to be at the end. Does not. Okay, did you do okay? Do you want me to do you want me to weights grade yours so you can check over it? Do you think you did okay? Okay. Yeah, yeah. All right, Anna, what'd you get? Good job. Okay, so number 6, make sure you have 10x squared y I squared of x. Brianna asked, does it matter where you put the I? No, doesn't matter. You can put it at the end, you can put it in the middle. The order of that does not matter. There's not like a standard form for these. Luke B. No. I is an imaginary number. So, no, I got what you're saying. Okay, number 7. Let's do this one together. So we need to break this down into square root of -1, square root of 64, square root of x squared, square root of n squared. Oh, is that n x to the 3rd? Yep. Sorry, I forgot about the x. Sorry, x. Square root of n squared, square root of n. Okay, so go ahead and simplify that. And I know this is easy. I'm going to have one of you guys tell us what the answer should be. Okay, Eric, what should the answer be? Good job. Okay, last thing I want you to do, and then I want to show you what a complex number is I want you to do 8, 9, and 10, and then we're just going to go over the answers. Okay, no. So 8, 9, and 10, and then we're going to do complex numbers for a couple minutes. Okay, number 8, Luke C. What'd you get? Good. 5i times the square root of 5y. So check number 8. Does anyone need me to go over that? Gigi? Okay. Gigi, number 9, please. Good. 20xi. Eric, number 10. Square root of positive 3n, you mean? Remember, oh, I thought you said -3. Didn't he? Okay. You're good. You just said it wrong. Questions on 8, 9, 10, Luke B. Variables are allowed to be negative, Luke. Well, just if you have a negative, oh, I see what you're saying. If there's a negative inside the square root, even if it's this, what would the square root of that be? What's the square root of negative x squared? Xi. And that would be a positive. Negative times a negative is a positive. Anyone else questions on this? Okay, I want you to flip your packet so that the orange page is on your desk, and I'm going to give you a piece of graph paper. So we're going to use this, and I want you to title it, and I'm going to give you graph paper. I want you to flip your packet, and I want you to title it complex numbers. So flip your packet to the blank orange page, title it complex numbers, and you're going to need the graphs just for part of it. This, it doesn't matter. I would say the orange one, but it doesn't matter. This is something I was not going to do, but this is good application for you guys before I explain and show you the quadratic formula. So just title it complex number. Oh, that was a little too big, but you should be able to fit it. Sorry. Okay, then here's what I want you to do. I want you to jot down the definition of a complex number, which is, and those of you that are absent, just use the back of the orange paper for this and just sketch your graphs the best you can on the orange paper. If it bothers you, see me in the morning, I'll give you graph paper. Okay, a complex number, here's how this is related, is a number of the form a plus bi. So here's what Luke B was trying to ask more about. That's why I think we should do this first. A and B are real numbers, but I is the imaginary unit square root of -1. Any other letter is a real number. A plus bi is a complex number because it includes a real and an imaginary number. Now you can write down whatever you want here, but let me show you. I made a little Venn diagram. Complex numbers in the middle because it includes a real and an imaginary. It's going to be an expression. Yes, we can graph them. So as a little example of what your part of your parabola would look like if this was an x-intercept, I want you to sketch a graph on your orange paper. This is the real axis. This is the imaginary axis. So 2 plus 3i, how do you plot that point? How do you know where it goes? It'd be over 2, up 3. This is the real axis. This is the imaginary axis. So if we had something like 2 plus 3i, this is where it would be. This is the real axis. This is the imaginary axis. Luke. Yeah. Yes. Oh, no, you don't need to label it. No, no, no. You just, technically. I mean, for these kind of problems, yes. You could think of it like that. Yes. Yeah. Yeah. You do not have to label it. You just need to know if you're plotting a complex number, this is the real axis, this is the imaginary axis. You do not need to label them. You just need to know that. Brianna, you okay over there? Just making sure. All right, so let's do an example. Number 1, I want you to write this on your orange paper, but then we're going to graph it on your graph paper. So I want you to write down 3 minus 4i plus 7 plus 2i. Okay, so first of all, what are we doing here? There's a plus sign in between it. What are we doing, Luke B? Right, we're just adding. So we're just adding like terms. 3 plus 7 is 10. Negative 4i plus 2i is negative 2i. Okay? So all we did was combine like terms. Let's graph. I'm going to put an R here. This is the real axis. This is the imaginary axis. I want you to sketch a coordinate plane on the graph paper I gave you. This is number 1. So sketch a coordinate, not that big, Kevin. Not the whole graph paper, just little. We're going to put a couple on here. So no, because it's just I. It's not I squared. You're thinking of I squared. No, the whole term's negative. The whole term. Nope, i's are still there. Think of this as negative 4x plus 2x. Correct. You leave it there. No, because you're thinking too much about that. Negative 4i plus 2i, Luke C. And Kevin, stop. Yeah, don't think of it like that. What's she doing? Is she messing around up there? Behave. Okay, let's graph. That's okay. She can see over there. So how do you graph this? 10 minus 2i. If the real axis is here, imaginary is here. Luke B. Okay. Good job. I want everyone to put a point here. Over 10, down 2. Over 10, down 2. And that is a complex number. There are real numbers and there's imaginary numbers. Is everyone with me on that? Okay, number 2, you're subtracting, but what do we need to do first? You're subtracting, but what do we need to do first? Remember this from chapter 9. What do we do with that negative? Luke C? Distribute. Good job. So we really have 2 plus 6i minus 1 plus 3i. So distribute the negative first. Now we're going to combine like terms. And this is on your orange paper. You should be writing this. So orange paper are the examples. Graph paper is the graphs. Okay, combine like terms. And someone tell me, what is that simplified? Eric, what'd you get? Good. So 1 plus 9i. Let me move this over. Because 2 minus 1 is 1. And then 6i plus 3i is 9i. So Andy, when we graph that, where do we go? Over 1 and then what? I didn't hear this. Good. Over 1, up 9. Remember, real axis is here. Imaginary axis is here. So over 1, up 9. Pretty easy, right? Well, you don't have to be a big fan of it. I just want you to understand it. Oh, good. There you go. Okay, number 3 and 4 on your orange paper. I want you to write down number 3, 9i times 3i. So now I'm switching it up. No more graphing. Let's just do some examples with complex numbers. Jared, what's 9i times 3i? Okay, Eric, I squared is what? Think back to our list. -1. Here's where the whole pattern thing comes into play. This is a big part of algebra 2. I squared is -1, so the answer to this is -27. So if you're multiplying complex numbers together, you're going to have to simplify, which means you need to know that pattern and have an idea of, well, what's I squared, what's I cubed, etc. Okay, 11i times -9i. Nathan, the first step takes us to what? Okay. Kevin, I squared is what? Good job. So -99 times -1, because I squared is -1. Your answer there, completely simplified, is 99. Still easy? Right, because we're multiplying complex numbers. Right. Good call, Gigi. Let's see. Let's skip those. Okay, number 7. I want you to jot this down. So 6 plus 3i, and then 4 minus 9i. So who can remind us the first step of FOIL? What would it look like? Gigi. Okay, go ahead. Do it for us. Okay. Good. Oh, 27i squared. You and me both forgot. 3i times 9i. Okay, next step. Andy, what would the next step look like? Which is? -54 plus 12. Good. Okay, I squared, Nathan, is what? Good. Okay, so after you realize, Luke, see you with me? I squared is -1. We need to keep simplifying. So 24 minus 42i, -27 times -1 is positive 27. So what's the answer? Anna? 24 plus 27. That's okay. Kevin? Good. 51 minus 42i. So will you have to FOIL complex numbers? Yes. Give me thumbs up, thumbs in the middle, because I know no one needs a thumbs down. What do you think about FOILing complex numbers? Okay. Number 8. I want you to do this one on your own. The first step of it. Do the first step of this on your own. So 3i squared minus 1, and then 2i plus 2. So do the first step of this on your own. The FOIL part of it. First, outer, inner, last. Just the first step on your own. Bless you. Okay, what is the first step after you FOIL? Brianna, what'd you get after you FOILed? Well, yeah, but do this first. So 6i cubed. Outer. Did you multiply everything together? Okay, keep going. Keep going. Okay, you didn't FOIL. All right, all right. All right, so FOIL. First, Luke, see? Keep going. You can tell us this first step. Good. Good. Awesome. Okay. Now, there's two things we can do. So, Kevin, I cubed is what? Listen to Jared. Negative I plus, Eric, I squared is? Good. So the second step after you FOIL, I think this is what Brianna was trying to tell me, is simplify your I cubed, I squareds, whatever you might have. So I'm going to rewrite this as negative 6i minus 6 minus 2i minus 2. Luke B, the answer is? No, to the thing on the wall.
Negative AI minus.
I'm just going to write it like this. Usually the real number is first and then the complex imaginary number. Remember our pattern that we went through? All right, hold on. Luke. Ready? Luke, look. Remember, I to the 0 is 1. I to the first is I squared is negative 1. Kevin, turn around. I to the third is I to the first times I to the second. You got it? Negative 1 times I is negative I. Do you understand how we got I squared is negative 1? All right, just checking. Anyone else? No, we'll stop. Yeah, let me explain your homework. That's enough. Do you guys feel okay? That's not you. That's from last year. Okay, in your listen. Tomorrow, what I'm going to do is we'll do a little review of imaginary and complex, and then quadratic formula all class tomorrow. So in your homework packet, I want you to turn to page 11. Oh, sorry, in the same packet I meant to say. Sorry. Same packet. Listen, hold on before you all start complaining. Page 11. Shh, guys, quiet. Page 11. You're going to do it all. There are only 14 questions. Shh, stop. Kevin, enough, okay? Enough yelling out. The 14 questions that are on here, these are not complex numbers. All it is simplifying radicals with a negative inside. You have 4 minutes right now. So I want all of you to get started. Okay, page 11, it's in the same packet. Tomorrow, I'm going to make a warm-up for you with just a couple complex number problems on. Please make sure that you have the pattern down of I to the 0, I to the first, etc. If you know the first 4, you know all of them because the pattern just repeats. Okay? So imaginary numbers, when you have a negative inside a square root. These need to be simplified completely. Oh, yeah, that's right. Hold on. Luke C needs to give a shout out. Go ahead, Luke C.
Hey, Brian. What's up? Just want to say hi and good luck today. Thank you.
If he actually listens to the lesson, we'll know. So don't even say anything, Joe.